The 300 Lonsdale Street building is a current project we're working on, and it's a CLT and glulam timber office construction, 20,000 square metre, 200,000 square foot, gross floor area, office tower over 11 floors, and it sits on the top of an existing 1990s three-storey shopping centre in the middle of the Melbourne CBD. We're extending that up with another 3 levels of retail in steel and concrete. But once we get through the retail and we started a new sky lobby, we've then got the timber structure, and we transfer that back to an 8.5 by 5.67 metre grid for double span CLT floors, sitting on lovely 680 by 480 deep glulam beams and 600 square glulam timber columns, which start at high strength grade and reduce in strength grade as we go up the building. All exposed timber, so no applied fire proofing. It is sprinkled, and we've done a lot of serious testing of members and components to justify a 90-minute performance under fire. And we've also had to do a lot of analysis to justify robustness or to design against progressive collapse. The issue of fire with timber is a big one, because we all put wood on the fire. I guess most of us, though, if you've been out camping and ever tried to get a big log to burn, it's not actually that easy. So getting timber ignited, mass timber, it takes a bit of time. People have trouble to understand that. There is also the principle of self-extinguishment. If you've got a big piece of timber and it starts burning, if there's not a fuel source to keep feeding it, it does potentially eventually go out. So the structural design for timber, it is just another material, but it does have its own unique and sometimes challenging intricacies. For the first point, it would be that timber is not timber. There's all sorts of timbers, and they're all different. And depending on where we're sourcing the timber from and what type of timber it is, whether it's beech forest from Scandinavia or a hardwood from Australia, there's about 100% difference in the strength characteristics of the material. So when we're doing working with the architect on the aesthetic and the sizings of members, without actually knowing what material you're using, you're sort of playing around with a lot of options. When you're working with any new material, there's a learning experience, and a lot of us structural engineers are pretty confident and we think we can do anything, but the reality is you don't know what you don't know. So if you are going to approach your first mass timber project, I'd say you do what we did, which is you bring on board people that have worked with it before and have some expertise in the field. The world, I guess, and the construction industry and the design professionals are really focused on climate change now in most parts of the world, and there's a lot of professionals around the world that have signed on to the Climate Emergency Pact, and part of the commitment of a lot of developers nowadays is carbon neutral or net zero carbon, and one of the easiest ways to achieve that is to build with timber. So I think while that sentiment prevails, and while also people look for more connection to nature, more connection to biophilic design, timber hits all of those boxes. So unless there's some major change in the world, I think the future of mass timber construction is only going to increase and increase.